Hello class, today we are starting chapter 12, which is about polygons and transformations. Today's lesson will focus on angle relationships and triangles. This is section 12.1a and c. Couple things for angle vocabulary. This is things you have heard before, but just to give you a refresher. There are four types of angles: acute, right, obtuse, and straight. An acute angle, as pictured here, is less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is more than 90 degrees. And a straight angle is 180 degrees. That's also a straight line, but if we're talking about angles, we're going to call it a straight angle. Part of our job in this section is going to be to name and classify angles. The name part, there are four different ways to name an angle. Your book is going to ask you to do all four of them. First is simply looking at the vertex and saying angle M. So this vertex point on the angle, you can name it just by that point. You can also name it, if it has a number, just by the number. So we could call it angle 1. Then we can get into the longer names where we start at one vertex, start at one point, go to the vertex, and then to the next one. So our next option is L, M, N. Or you can reverse it and go N, M, L. So those are our four options for naming that your book is looking for. When it's talking about classification, that's using acute, right, obtuse, or straight. This angle is acute because it is less than that 90 degrees. Other angle vocabulary that we have, vertical angles. These are congruent, opposite angles that are formed when two lines intersect. So we've got our two lines running into each other. The vertical angles are 1 and 2 are the first pair of vertical angles, and then 3 and 4 are the second pair. So 1 has the same measurement as 2, and 3 has the same measurement as 4. Adjacent angles are two angles that share a vertex point and a common side. So we have this middle side that both angles 5 and angle 6 are touching. So angle A, B, D, we'll stick that last point on there, ABD is adjacent to angle CBD. So these two that are touching but not overlapping are adjacent. Couple other terms that we have, complementary angles. Those add up to 90 degrees. They can be adjacent where they are touching, or they can be separated. As long as they add up to 90 degrees, they're complementary. Same kind of idea happens with supplementary, but those add up to 180 degrees. Again, they can be separated, or we could push those together and have them be adjacent as long as they add up to 180 degrees. So, we are going to look and see if these are vertical, adjacent, complementary, or supplementary. So we're going to go ahead and check the addition of them. They're not vertical because they're not across from each other. They're not adjacent because they're not touching. So we're going to go ahead and add them up. 54 and 26 gives me a grand total of 80 degrees. They don't add up to 180 or 90, so this would be none of the above. Not complementary, supplementary, vertical, or adjacent. If I come over here, looking at angles 1 and 2, they aren't vertical because they're not across from each other. They are adjacent because they are right next to each other. And then if we look, these two, when I put them together, form a straight line. So they are also supplementary. So they're adjacent because they're next to each other, and they're supplementary because they add up to 180. We can also use these ideas to help us find missing angle measurements. So right now we are looking for the value of x. In order to do that, we need to use the information that we're given. So we're given that 46 degrees and x. The relationship between 46 and x is that they form a straight line or that they are supplementary. So in order to find x, we're going to take our 180 degrees and subtract the 46 that we already have. After I do that, I end up with an answer of 100 134. So angle X is 134 degrees. Now it's asking us about angle 3. So we have to figure out the relationship between angle 46 and angle 3. In this case, we've got our pair of intersecting lines, this first line and second line. When I look at 46 and 3, those two are across from each other, so that means they are vertical angles, which means they are congruent. So angle 3 is also 46 degrees. We're also going to talk about triangles today, which is a geometric figure that has three sides and 3 angles. When you are looking at the total angles for a triangle, they have to add up to 180 degrees. There are 3 ways to classify triangles using their angles. You are always going to look at the biggest angle. So with this first triangle, 52, 58, and 70, 70 is my biggest angle, so I'm using that to classify. Since 70 is acute, we call this an acute triangle. Coming over to this middle one, we've got 35, 40, and 105. Our biggest angle is 105, and we're going to classify this as obtuse because 105 is greater than 90 degrees. Then we're going to look at this last one. We've got 43, 47, and 90. Since it's a 90-degree angle, it is a right angle, which makes this a right triangle. So there are the 3 different ways, acute, obtuse, and right, to classify by angles. We also can talk about triangles based on the number of congruent sides. So that is the number of measurements that are exactly the same. One thing to note is if they don't actually give you measurements, these dashed lines are meant to tell you that those sides are the same. So I could say 3, 3, and 3, 7, 7, and 7. Those dashed lines are meant to tell you that they are the same size. So if we've got a triangle with no matching sides, we call it scalene. If we have a triangle with all 3 matching sides, we call that equilateral. And if we have a triangle with 2 of the 3 sides matching, we call this isosceles. So scalene is none, equilateral is all of them, and isosceles is 2 of them. So our job now is to classify the triangles by both angles and by sides. So I'm going to go through and look at this first one. The biggest angle is my 90-degree angle, so it's a right triangle. There are no markings on any of the sides, which means they're all different. So this is a right and scalene triangle. Coming to the middle one, I've got 68, 44, and 68. The 68s are my biggest, so that is acute. And then looking, I've got 2 dash marks, which means 2 of the sides are the same, giving me an acute isosceles triangle. And then coming over to the last one, I've got 60, 60, and 60, so all of them are the same. It's an acute triangle with 1, 2, 3 dash marks, so that means all the sides are the same. So it is an acute equilateral triangle. Other things we could do with triangles is find the missing angle because we know that they have to add up to 180 degrees. So in triangle ABC, if angle A is 25 degrees and B is 108 degrees, find the measure of angle C. The first thing you need to do is add up what you know. So I'm going to take 108 and 25 and add them together. And that is going to give me 133. I'm then going to take my 180 degrees, so my whole triangle, and take away what I already have, which is 133. After I do that subtraction, I'm going to end up with a 46 for an answer. So that means angle C is 46 degrees. Same kind of idea, but now instead of giving us a sentence, they give us a picture. We still want to start by finding out how much we have. So 119 plus 43, which gives us 162. You're then going to go ahead and do that subtraction from 180 to find out what's left over. So minusing 62, we end up with 18. So that means the measure of angle Z is equal to 18 degrees. Now that you're done with the video, you can show your notes to the substitute and get your homework slip.